68%, 95%, and 99.7%. So what does this mean? 68% data fall in 1 standard deviation, between 1 standard deviation. 95% data fall between 2 standard deviation, and 99.7% data fall in 3 standard deviation. That's the meaning of that. Well, let's see visually. Okay, so if we draw a normal curve, basically, right? So as you see the peak that's down here is the mean. So that's the mean, and of course this is negative on the left side and positive to the right side. And in a normal curve, and this is a z-score curve, and normal curve, area under the normal curve is 1. This is a 50% and this is a 50%. Right from the mean to the right is 50%. Right from mean to the left is 50%. So 1 standard deviation. What is 1 standard? Between 1 standard deviation, -1 to 1. That would be basically 1 standard deviation. So let's actually draw it here. So if I have 1 standard deviation, so this is going to be my 68% data. In other words, this is 68%. Falls between 1 standard deviation. That's 1 standard deviation. Okay, let's take a look on 2 standard deviation. How it looks on 2 standard deviation. So in 2 standard deviation, we have, that's a 2 standard deviation, and also -2 standard deviation. So whatever data here is 95%, almost 95% fall in between this. So this is -2 to 2 standard deviation. It's falling this one here, 95% data. So again, this is a 95% data, and this is 68% data. And now I'm going to draw another one. Okay, so this is another one down here. So I'm going to show this 99.7%. How many standard deviation? 3 standard deviation. So it's going to be from this point to that point. So 3 standard deviation. So all this data fall between almost 3 standard deviation. 3 standard deviation. So this is down, this one coming up here. This is a 99.7% data fall between this. Again, I can have this one here. So that's basically 99.7% data falling in this. So just visually to see again, 68% fall in 1 standard deviation, 95% fall in between 2 standard deviation, and 99.7% fall in between 3 standard deviation. Between 3 standard deviation, -3 to 3 standard deviation. Once we understand this, let's see how can we use this in terms of empirical rule. I'm going to erase this one here on the left side here, or I can actually create another one down here. I'm going to create another one down here. So if I create another one down here, let me see. I want to make sure we understand that. So this is the mean, that is the mean, and that is 1 standard deviation. 1, that is a 2, that is a 3, that is a -1, that is a -2, and that is a -3. Again, this is the mean, this is 1 standard deviation. How far it is away from mean? 1 standard deviation. So I can put down 1 standard deviation, 1 standard deviation. Or I can use the red color here, 1 standard deviation. This is how far? 2 standard deviation. This is how far? 3 standard deviation. And on the left side, so mean plus, this point is a mean plus. Again, I want to reiterate it here, this one. This one is mean plus 1 standard deviation. This one is mean plus 2 standard deviation. This one is mean plus 3 standard deviation. And on the left side, of course, this one is mean plus 0 standard deviation. On the left side here, mean minus 1 standard deviation. Down here is mean minus 2 standard deviation. Down here, mean, population mean minus 3 standard deviation. So this is what is meaning. This is what it means actually. So well, if mean is not 0 and standard deviation is not 1, with non-standard normal curves. Non-standard normal curves. So I'm going to actually create one here. So again, same thing here. Especially same thing. So this is 1 standard deviation. 1 standard deviation. Now I'm going to show everything at the 1 point here. So that's 1 standard deviation. That's a 2 standard deviation. That's a 2 standard deviation. That's a 3 standard deviation. That's a 3 standard deviation. Now, if I put down this is 50% here, this is a 50%, 50%. What is this much from the mean to 1 standard deviation? What percent of data fall in that? So we know that between 1 standard deviation is 68%. So I just cut in half, slice it. 68 divided by, I will just divide it. 68 divided by 2, it should give me 34% and 34%. Let's do this. 34, 34. And of course it's percentage. And next thing I can work it out here is going to be the next piece here. So well, if I want to know what is the percentage here versus what is the percentage here. So well, if I want to find this out here or that one here, we know negative 2 standard deviation to positive 2 standard deviation, negative 2 standard deviation to positive 2 standard deviation is 95% data. So if I can somehow subtract 95 minus, we already know 68% data. So 95 minus 68% data, so we can use any simple calculator. So 95 minus 68% data enters 27. So this one plus this one, these two boxes is 27. So if I want to find this one, I'm going to cut this up again, divided by 2. So it's going to give me 13.5. So this piece is going to be 13.5. 13.5. That is going to be 13.5. Of course, percentage. Okay, now how about this piece here? Okay, so how about this piece? So we know this is a 95%, but this is from this negative 3 standard deviation to positive 3 standard deviation is 99.7%. It's down here, 99.7%. So if we somehow subtract 99.7%, let's do this here, 99.7 minus, this is already we know 95%. So we already, this is known. So we know it 95. Enter. So 4.7%. Remember, this piece and that piece is 4.7%. So I'm going to divide by 2, get one piece. So divide by 2 is 2.35%. So this is 2.35 in this one here, percentage. This is 2.35 percentage, this one here. So again, this piece is 13.5 and this piece is 13.5 in both sides. I'm gonna make it different here. So okay, now how do we find the remaining percentage here? The remaining percentage. So remaining percentage, we know 100% minus 100 minus 99.7. This is 0.3 divided by 2. And that would give 0.15. And that is extreme. We don't really go about that. This is really outliers. Well, between 2 standard deviation is a normal. So from here to there, this is called normal or usual. Z value between negative 2 to positive 2 is a normal Z-score. Almost 95% data falls in between. And whatever to the right side or left side is like extreme outliers. We don't really go with that. So this is how we find all the pieces necessary for to use the empirical rule. So if we understand how we get these pieces, then we can deal with any kind of problem given to us. Let's actually take a look here. Given mean is equal to 100, standard deviation is 10, find probability of 90 less than x less than 110. Here you go. How do you find that out? Okay, so first thing we do, we create a normal curve. We create a normal curve. Okay, so right below the fig, we're going to put down the mean. So the mean is, in this case, is 100. So that's 100. Now, this is going to be 1, that's going to be 2, that's going to be 3 standard deviation. Always like that, 1, 2, 3 standard deviation. Okay, so this one is mean plus 1 standard deviation. So mean is 100 and 1 standard deviation is 10. 10 times 1 is 10. So 110. So that's 100, 110, 110. Bingo, we have that 110 already up here. So now we are looking for 90. So most probably 90 is here. Why? Because mean minus 1 standard deviation. So 100 minus 10 is 90. So that should be 90. So I'm going to have this vertical line here. I'm going to have this line here. So that's 190. And of course this is, so the 110, my apology, 110 and that's 90. This is what question is asking. What is the probability between these fish? So if I look into z-score fresh captive, let's do this one. Right here is a 0 and that is 1 and that is negative 1. So we know this from here to here is 68% data. So our answer is going to be 68% probability that it will fall into this 1 standard deviation. So answer is 68%. Okay, let's have one little bit challenging one here. Okay, so let's do this one here. Given mean is equal to 7.6 and standard deviation is 0.4, find the probability by using the empirical rule. Don't use the z-table, just empirical rule or this. So let's take a look, we can find out. So what is the first thing we do? We are creating a curve. So well, if we create a curve down here, that's a normal curve as you see. 3 to the right, 3 to the left. Now what is the mean? Mean is 7.60. So I'm going to write down here on the bottom here, I'm going to write here 7.60 instead of 0. 7, well I'm going to write down 7.6. That's the mean. Now standard deviation is 4. By now we already know we're going to add 0.4 to this one to get that. So this is going to be my 8. That is going to be my 8. Now let's fill this out. Then it's going to be 8.4. 8.4. 8.4 with a simple arithmetic. And then of course 8.8. Next one is 8.8 with a simple arithmetic we can add. Now we're going to do the same thing on the left side. We're going to subtract. So it's going to give us 7.6 minus this 1 standard deviation is going to give us 7.2. So 7.2. And on the left side, I'm going to keep subtracting. It's going to give me 6.8, 6.8, and it's going to give me 6.4. Very nice. So this is the first thing we have to do. We have to translate into a normal curve, which is a non-standard normal curve in this time. Now we look into here. So this is x greater than 8. Well, by the way, this is the x value. This is not a z value. This is the z value here. Z value is always between your mean is 0 and of course between 3 standard deviation. Well, it's between 4 standard deviation, but yeah, we go maximum 3.5 in z-table. So we're not using z-table. We are using this empirical rule. So well, probability of x greater than 8. X greater than 8. Here you go. That's the x greater than 8. So we are going to actually highlight it here. X greater than 8. So if you look into here, x greater than 8. So that's basically x greater than 8. So we are looking something to the right side here. That's basically to the right side. What is the area probability here? So notice that if we look into, we already mentioned up there. Let's take a look here. All the sectors we mentioned up here. So if we look into this, eyeball into this one, we know this is basically, well, you can look into, you create whole thing again, or you just look into that. So that fall into what? I have 1 standard deviation all the way to 3 is standard, 3 and more. So you go down here, 1 standard deviation all the way to this, you know, is 13.5 plus 2.35. We can use any little calculator. And this piece is basically 0.15. So actually we have a 13.5 plus 2.35 plus 0.15. That is a 16 actually. That's 16 down here. 16%. Now I can do it a little bit different way. Instead of going over that one, we know from 1 standard deviation, is going to be 68%. So this is going to be 68%. 68%. That is going to be 68%. But I have something here on the left side. So this is 68%. Now what is this total? Total is going to be 100% here. So 100, well, total is 100. So 100 minus 68. So 100 minus 68 is going to give me 32. 100 minus 68 is going to give me 32. So what is that 32 is coming up from here? So 32 is basically from this side plus that side. It's a symmetric about both sides. So 32 should belong to, this is going to be 16 and that is going to be 16. In other words, you divide by 2, which is 16%. So that is going to be 16% and that is going to be 16%. So that's how we can get this without looking into everything. Again, how can you do that? Since you know x greater than 8, so we are looking or interested to the right side and assume we don't know that. So to the right side. So but we know that 1 standard deviation, is 68%. And now we look into everything else and that is going to be 100%. So everything else that is going to be 100%. So if it is 100%, is going to be 100 minus 68, which is 32. And 32 it's going to be basically the remaining piece here. 100 take away 68 is going to be 32. In other words, this side is 16, this side is 16. This one plus this one is 32. So we are not interested in both sides, we are interested in only one side. So divided by 2, that would be 16. So that is 16%. Okay, so that's how we find that. Now, if we look into the next one here, x less than 8. So x less than 8, I'm going to erase this mess here. Well, actually, instead of erasing, I can use the different ink here. We are looking area this side. We are looking area on that side, left side. What is the area? Less than that. So 100 minus 16. So we can just do like that actually. 100 minus 16. Well, I can actually erase all this mess. Okay. So since we know this is 16%, we are looking to the left side here. This body we are looking for. So 100 minus 16, it should give us 100 minus 16. That's 84%. That's 84%. So this is going to be 84% because we are looking to the left from here to the left. 84%. So that's, we had, this is 16%. This is 84%. How about this one? 0.68, 0.68 to 0.8.4. Okay, so seems like negative 2 to 2, positive 2. So by empirical rule, we know it's going to be 95% data, 95% data. So that would be 95%. That's how we use this empirical rule to find the probability without going through the z-score. Even you convert it to z-score and you go to the z-table, your answer is going to be same approximately. So I hope we understand how to use the empirical rule and how it looks like, and that's a breakdown step by step. You can go back, pause the video and check your answer again. Thank you.